Okay, hi, in this video we're going to try and find the sum of an infinite geometric series. So that just sounds a little bit crazy. So I wasn't sure if you guys read what I put in the module, but infinite means it goes on forever. So how are we going to add this? Well, you really can't unless the ratio is decreasing my number. So you'll see my fractions are getting, these numbers here are getting smaller and smaller as we add them. In fact, if we go on forever, they're going to be so minuscule, the numbers, that it's really not going to affect our sum. Okay, it's just going to be, they're just too small to even do anything. It won't fit on your calculator or anything. So we call this an infinite geometric series, and we will be able to find the sum if it meets the condition where it's decreasing and not increasing. So how do we know if an infinite geometric series is increasing or decreasing? Well, what we need to do is to check the ratio. If our ratio is in between -1 and 1, we're good to go. We're decreasing, we can find the sum. So that's what we need to do. So we're going to go ahead and let's check what our R is. If you recall, it's just A2 over A1. So in this case, this is just going to be 3 over 16. Oops, don't forget the negative. -3 over 16 divided by 3 over 8. Now for me, when I have a complex fraction like this, I like to write it horizontally because it's easier to divide our fractions that way. Okay, and then we just keep the first term, change division to multiplication, and then flip my next, flip the second fraction. And then here we can just reduce this here. And we get 2, oops, made a triangle for me. We get, whoops, this becomes 1 and this becomes 2. So basically when we multiply this, here, let me write it again up here. So -3 over 16 times 8 over 3. The 3's cancel out. This becomes a 1. This becomes a 2. This becomes a 1. This becomes a 1. And we end up with -1/2. So my ratio is -1/2. So -1/2 is definitely in between -1 and 1. So this means that my infinite series is actually increasing. Decrease, and it's decreasing so far that it'll end up being close to 0, so we can go ahead and find our sum here. So the way we're going to find our sum is we're going to go ahead and use the formula. Here, I'll switch colors so we don't get confused. Our sum is actually just a to the 1 over 1 minus r. So that's all we have to do here. So my a to the 1, as you know, is 3 over 8 divided by 1 minus -1/2. So this is just 3 over 8 over 1 plus 1/2, because I've double negative. Rewriting this as a fraction, we're going to have 3 over 8 divided by 3 over 2. And again, I have another complex fraction. So I'm just going to go ahead and rewrite that as 3 over 8 divided by 3 over 2. And again, we'll go ahead, we'll keep the first one, change to multiplication, and find the reciprocal. And look at that, everything crosses out all nice. And this turns into a 4. So this is just 1 over 4. And that's it for this video. So the sum, whoa, I really did something crazy there. I hope I didn't make you do it. So the sum of this series right here is actually equal to 1/4. You're like, wait a minute, notice it's plus and minuses. So that's how it turns into 1/4 because we're subtracting and adding. And that's the end of this video.